I'm going to show you how to work with equality. And the example that I'm going to look at is one of the examples that I skipped in the lecture. So let's have a look. So up here we have the imports that we will need to work through the example. And you will remember that already in the first lecture we defined the reverse function, which reverses the order of a list. And it uses an auxiliary function called rev, which is defined up here. And the way you think of this is axis is the accumulator that is accumulating the reversed list, and we are recursing on the second argument. So when we reach the empty list, the accumulator will contain the reversed list, so we return it. And if we have a composed list, a non-empty list, then we just add the head of the list to the accumulator and we proceed recursively. So we can try this. For instance, reverse 1, 2, 3 gives us 3 to 1. Now, suppose we want to prove the following statement, given any set A and a list of x's whose elements are from A. We would like to show that the length of the reversed list is equal to the length of x's. So you would write it like this. So actually, let me start the definition from here. So you say, okay, how do I prove this? So the first thing I look at, by the way, is if there are any explicit arguments here, but there aren't any. There are two implicit arguments, so I just leave this empty here. Press Ctrl+C, Ctrl+L. And now I say, well, what can I do? And I have to think what will be the procedure for doing this. And because reverse is just a call to this rev business, I expect that really to prove this equality, I really need to prove something about rev. So there's going to be some sort of an auxiliary lemma or a statement about rev that is going to help me. And I should think about what it is. So the way you think about it is you start by looking at how does it reduce? So what does this reverse have to do with rev? So if I press Ctrl+C, comma, it's telling me, okay, you have to prove length of reverse equals length. But if I do a little more, oops, that was a bit too much. Well, but I'll do it. You see that, so this was now Ctrl+U, C, comma. It's just immediately reducing this. Okay, so I have to say something, and this is just a fancy way of writing the length function here. So the length of ref empty set x equals the length of, this is the length of x's. So you would think that the auxiliary lemma, whatever it is, would be, so let me set it up. So right now I don't really know what it is, but it's something like, maybe it's something like empty and x's, because that's what I see here. Okay, so it would be maybe length of this equals length of x's. And I can immediately try if this is going to work. Okay, it doesn't know what x's are. Okay, so why is that? Well, that's because I never told it that we have x's. So I want this, but actually this won't work. It would think that this is the first argument. So I have to say a and x's. So I will need these implicit arguments. So I put them here. Try again. Okay, so now it's happy, and I can see, will you be happy with this lemma if I give it to you? And it says, yeah, I'll be happy. You just have to prove the lemma. So now I'm proving the lemma. So this is the most naive way, where I actually just wrote down the lemma that is precisely what I need. But that's not going to work really, because rev is recursive, and this is just the top level call to rev. What I need to think about is a more general case. Well, what is the general case? The general case is not when the first argument is empty. It's when the first argument is a general argument. Also, let me just do a little thing here. It's confusing me that I have x's here and I have y's here and then I have x's here again. So let me let me rename these to z's. It'll be easier to talk and think. Like this. Okay, I press Ctrl-C, Ctrl-L to check that everything is okay. Okay, so what we really need to do is we need a lemma that is about this function in the general case. This is a special case when the first argument is empty. So the general case is going to have here something else. Let's say we'll have, I don't know, w's, or, well, w's is fine. So I have to say, what is the length that rev is going to return when you have a general state of your accumulator use and you still have to process z's. And if you look at this and you say, well, what is going on? It's just placing all the arguments in the second list inside the accumulator. So at the end it'll just add them all up. So this is where you need a moment of brilliancy to figure out that this is going to be the sum of the lengths. So this would probably be a better lemma to prove. So this step was very important. So let me repeat what I did. First, I figured out that in order to prove the statement that I want to prove, now it doesn't know about the use. Okay, so we'll have to do something here. Let's fix this. So it'll say, okay, if I have any u's and z's, which are list A, then, okay, I have to write it like this. So just to repeat quickly how I got here, okay? So I said, I'm trying to prove something about, this was Control-C, comma, Control-C, Control, comma. I'm trying to prove something about the length of reverse, but because reverse just calls rev, I really need to prove something about rev. But the thing I need to prove about rev is not just what happens when rev is applied to the empty list. I need the general case, because this is going to recursively call itself and then it'll get to the general case. And this is a common thing. If you see that there is an auxiliary function that is getting called, you will have to prove what that function is doing in the general case, and then the special case of that function is going to prove your main theorem. So now we can make some progress here. Okay, so my auxiliary lemma, I would like to use it. So how will I use it? Well, I can press Ctrl-C, Ctrl-R, and Agda says, yep, you can use it, but you have to tell me what the u's and the z's are. So I'll just press Ctrl-C, Ctrl-S to see whether Agda already knows this. No, it doesn't. Oh, but it's Ctrl-C, Ctrl-A says, yep, you could use empty, which is not surprising, right? If it wants me to set this to empty, and then it'll say, I bet it'll say, set this to z's. Ctrl-C, Ctrl-A. Okay. So at this point, I know I will be done, provided I can prove the lemma. I'm now going to stop for a moment to think whether I formulated whether this lemma is true, because if I'm trying to prove something that's false, I'm going to have a problem. But yes, this should work, because what rev does is it's going to take all the elements of z's, put them inside u's, and then return u's. So this equation should hold. So now I should try to prove this. Okay, so now how do I prove this one? First of all, let's give a more intelligent name to this. So let's call this length rev. Okay, like this. Okay, so how will I prove this? Let's look at the goal. Ctrl-C, Ctrl-comma. Again, okay. It says for all use as is. Okay, so let's give it a name. Use. Oh, now it's good. Now, see, this z's1 is here because I have z's and then I have more z's. So let's restore symmetry in this universe by calling this v's, like this. And so earlier I forgot to look at the explicit arguments. This thing wants two explicit arguments, so I'll just put them here. So if I were a little more careful, I would type this, then I would press Ctrl-C, Ctrl-L. Okay, so now we're staring at this and we say, how are we going to prove this? Well, we can't prove this without looking at what rev is. So rev is defined up here. And because rev is defined by recursion on the second argument, you see, it's pattern matching on the second argument. That makes me think I should also try to prove this statement about rev by doing induction on the second argument. So I say, please consider the cases for v's. And then it says, okay, you first have to say what's this. Okay, so now I look at the goal, Ctrl-C, Ctrl-comma. And it says you have to show me that the length of use equals the length of use plus length of empty. But length of empty is 0. So this is just saying n equals n plus 0 for some n. So now I need to prove that n, so I want to say n equals n plus 0. I will first try REFL to see if it works, and it doesn't work. It would work if this were the other way around, if this said length empty plus length US, but it doesn't. So now I need a lemma that says n equals n plus 0. I could try to prove this by hand, but let me show you how you would find this in the library. So nat properties here has a bunch of useful lemmas. Let's speak in here. See? Pages and pages of lemmas about order and about natural numbers. Okay, so this is horrible. Okay. I go in here and I say I will search for a certain thing, which is Control C, Control Z, and I tell Agda, show me all theorems about plus. And now, oops, sorry. Oh, let me repeat that. It disappeared. Control C, Control Z. Show me all theorems about plus. And here I have now, oh, no theorems about plus. Okay, that means I'm going to record all these mistakes because you're going to make the same, you're going to have to do the same thing. So why isn't it showing me? It should have a bunch of theorems about plus. So again, I'll just try again. Nope, there aren't any. Apparently, I'm not opening the correct thing. Open data nat properties. Let me look at this a little bit. So for instance, there should be something that says something like n plus 0. Okay, there's an n plus 0 here. That's the only one. Okay, let's think. Let me try if there's something wrong with this search about. First of all, let me check that I'm doing the right thing. Search about should be, okay, search about is Control C, Control Z. Control C, Control Z. Let's try to find theorems about successor. It's just not showing me any theorems. Okay, thank you very much. Okay, I know that this worked in the second lecture. So I need to check. I'm going to go to the second lecture in Agda mode. Okay, run this. Find the reverse length. Length reverse. Okay, and I'm going to try to see whether I can search about. So I'm going to put a random hole here and repeat the exercise. Control C, Control Z. Show me theorems about plus. There's a bunch of theorems about plus now. See? Okay. So what's the difference? Well, the difference has to be in what is being imported. So let's search imports. Okay. So open import data nat properties, which is what I thought was needed. Did I import this? Okay, but I also imported, okay, there's this stuff that's being imported. Anything else? Okay, this is also imported. Data fin hiding plus, I don't think that makes a difference. Interesting problem. This one here doesn't want to work. Okay, I'm going to give up on trying to search for the theorem because it doesn't want to work, and I will look elsewhere. I'm going to look directly inside here where I think the lemma that I want is, and I'm looking for something revolving plus and how plus 0 something. Okay, so this, for instance, is something about successor, associativity, identity. This is looking good, but it's a bit unreadable. So left identity. 0 is a left identity of plus. I need the other one. I need the right identity. So this might be the right thing to prove, to use, but what is this? Okay, so now there are two options. I can go and look at these definitions without this definition, and then it says something about something being a right identity in a general monoid, and I don't want to look at that. There is a better way. If I suspect that this is the theorem that I want, I copy it, go back, I put it in my hole here where I want to use it, here, and now what I do is I press Control-C period, and it says, okay, you need this, but you need that, you have that. And this is not very descriptive because I would need to understand what algebra definitions right identity is, but there is a better way. I can say to Agda, please compute what this is. And this I do by pressing Control-U, C period. Ah, now it computed, and now I see what it is, and it's x plus 0 equals x. So this is the thing that I want. Okay. So this one says x plus 0 equals x. Let me look at my goal again. X plus 0 equals x. Oh, it's the other way around, you see? This one is length of US equals length of US. So what I need is I need to turn this one around, and that's symmetry. So I want symmetry of this. So I will first use symmetry. I say, please use symmetry. Control-C, Control-R. It says, okay. And now it's the other way around. Now I say, let me show you again. Yep, this is gonna work because if I take for x, now it's this. Okay, the upper one, it computes what I have, but it also computed the goal. So now we can't compare them. Anyhow, if I think this is the theorem that I can use, I press Control-C, Control-R, and it'll try to use this one. And it says, yeah, I could use this one, but you have to tell me what to apply it to. And I can try Control-C, Control-S. No, this is too ugly. So what do I need to apply it to? Control-C, Control-A. You see, it's giving me an answer, but it's computing it too much. This is super ugly. Now I know this is length. See, it worked. But what do you do if you don't know? You're here, and okay, so the thing to do is, before you apply the theorem, you can do it slightly differently. While I still had just a hole here, see, here I am. I want to show length of US plus 0, because this is 0, equals length of US. I suspect that I can use this theorem. So instead of pressing Control-C, Control-R, I can try to already instantiate it. So I say UUC period. Okay, it wants me to specify what the x is. And I look at the goal and say, well, the x is supposed to be length of use. I see. So before I apply the theorem, and then it wants me to fill this in, I remember what this is supposed to be. So I just was a bit smarter about that. Okay, so this one went okay. Now how about this one? So now this one is more interesting, and it says the length of rev of this business here equals the length of this thing here. Now this one is probably going to be a little more complicated. So first of all, the length probably does something. So let me press Control UUC comma. That means show me the computed thing. Ugh. Control UC comma. It's just, okay, maybe I just need to do this. Sometimes you need to do things, think about these things sort of a little bit by hand. So what is this going to do? This rev here is going to make a recursive call. So it's going to put x into use. So this is going to be length of rev of something else. And this is going to be the sum of the lengths. Okay, I don't see really how I'm going to prove this, but I know at least how to set things up. And the way that I'm going to set this up is I'm going to do reasoning line by line. So if you want to do reasoning line by line, you need a thing that's called equiv reasoning. Is it capital? Reasoning. Okay, this is inside the definition when you include a propositional equality so that you have the identity type. It's down here somewhere, reasoning. It's somewhere else in here. It's included in one of these things. Anyway, let me show you what it's like. Oh, I could just go here and press Alt period, and then, yep, here it is. So it contains some useful stuff for reasoning. So you just open it. This means open it only locally in this where definition, which is neat. And now let's do this. Okay, so the way you set this up, you say, I'm going to have a line-by-line reasoning of equality reasoning. So the way that you do, the way this is going to go is going to be something, and then here QED, okay, begin, this is end. And the thing that I want to use is this funny operator, which what it does is you put here your left-hand side, then you do one step of reasoning, and then you make progress, and then this question mark, we'll see where it goes. Okay. So now I press Control-C, Control-S, and Agda says, yep, that's the left-hand side. You need to show me the, okay. And now I'm thinking about what can I do with this left-hand side. I need to make progress. Okay, so the length of the rev of the use let me see what the goal is, Control-C colon. Let me see what the normalized goal is. Okay, I just need to stare at this. This is, maybe one thing I can do is this. I can put it here and replace the silly folder successor thingies with length. There we go. Okay, so this is what it's telling me. The length of here, this stuff here equals the length of this stuff here. So actually, so I just need to do something with this. Okay, but if you compare, I have length of rev on this list, but now I have length of rev on a shorter list. So actually, I should be able, so this thing here is actually length of a shorter thing. So maybe I could try using the recursive call. So if I say, what is the length rev of, what does length rev, so induction, because I see that I have length rev of this. So length rev, when I have, instead of having use and x's, I will have x, use, and v's. What is that? Okay, so Control-C, Control period, and it says, ha, okay, it's telling me that in here I have a proof of length of rev equals something. So, well, at least it's progress. So let's try to use this. It doesn't want to use this. Oh, that's because it insists that I have to do everything in one step. So here, I think I should, let's see, I think maybe this is the way to do it. Okay, yeah. So that QED meant that when I had this QED business here, that was forcing the last thing to be the right-hand side, and I'm not yet at the right-hand side. So I'm here and only now. So what happened so far? So far, so far I said, this is the left-hand side. And by applying the induction hypothesis to a slightly shorter v's without the x, I get someplace. And now I need to do what? I look at the goal and it says, well, now you have the right hand. Now I made one more step. See here, this is the one more step, and you still have to do the right hand side. Okay, now what? How are we going to make progress? So what is this business? Well, this is still, again, let's see. It's a bit unfortunate that it's unfolding this length. So it wants me, okay, so it says what we got, what we really have at this moment is this is my left-hand side, okay? So it's showing it unfolded. So what are we going to do about this one? Successor of the length of the v's. Again, what is my goal? Yes, so this is the right-hand side, this is the left-hand side. Let me copy it here. I don't know of a better way of showing you what needs to be done. Okay, so this is what I'm really trying to prove now. Well, this one here should be just length plus 1, or actually probably just successor of length. That seems more, right? So okay, successor of the length of this equals length plus successor. Yeah, that should hold. But is there a lemma like that? Well, it might be worth checking if there's a lemma. So what is the lemma that I would want? So the lemma that I would want is successor of x plus y equals x plus successor of y. Because if there's a lemma like that, then I'm done. So can I find the lemma? Well, I go in here and I say, well, this is going to be a bit plus, oh, look, plus successor. What does it say? It says m plus successor on the second argument equals successor on the of the sum. Okay, so this is the one I want, but it's by it's the wrong way around. But this is the one I want. So I'm gonna use this one. Where am I? Ah, here. Okay, so I want to use it. So how will I use it? I will say, okay, we are going to use we're going to want to use a lemma here. So first of all, the lemma that we want to use is this one. And then let's fill this in. Control C, Control S. Okay. Why does it know what's supposed to be here? It knows because it knows that this thing is a proof that goes from here, equality of here to here. So it's just filling it in. So Control C, Control period. Yes, okay, I want this, but this is what I have. Oh, also, look, yes, so symmetry. I have the successor on the left-hand side, but here the successor is on the right-hand side. So I actually need the symmetric version of this. So up here earlier we used sim. Let me show you another way. So there is another one of these funny thingies which you use if you want to flip things around. So it's called this. I press U, curly brace close. You want this funny bit. This is like a subscript U. It's like an accent that looks like a U. And the way I typed it was \U, open brace, close brace. So this one will just flip around the proof that I want. Okay, Control C, Control L to see if everybody is happy. Yes, and this is the one that I want to use. How about if I just do, okay, so now again, let me think a little bit about how I want to use it. What is M and what is N? So, Control C, comma, no, this is getting, okay, so here I can see them. One is U's and the other one, no, one is length of U's and the other one is length of V's. Okay, so this one should be length of U's and the other one should be length of V's. Control C period. Okay, let me try if it works. Control C space. Oh, look, it accepted. Also, colors got better. So, what do I have here? Am I done? I should be done, right? If I think I'm done, then I press QED. I type QED here. And Control CS. Yep, I'm done. I win. Because I got where I wanted to be. Okay, that's how I would do it. And there are people who can do this much faster and better than I can do, but, you know, I can get along. So, again, the important bits were, okay, so what were the important bits? Figuring out that because my function calls another function, I will really need to prove a lemma about the other function. So this proof was about rev. It wasn't so much about reverse. And I needed to prove a general lemma about rev, not just the case that I'm actually interested in, because rev is recursive. And so the calls will unravel and I'll get to the general case. That was an important thing. Okay, so then an important thing was I didn't know how to search for this. But then I just searched through this file and it was okay. For some reason, search in this file didn't work, but in the other one did. Somebody can tell me in the comments why that was the case. What else? The reasoning thing. Okay, so the reasoning thing here is you say, I'm going to do a line-by-line reasoning starting with the left-hand side. You do begin, this is the left-hand side, and then you use this operator, which makes one step of reasoning. This is a proof of that step. And we also learned that there is another one that just flips things around. If I didn't use this, I would then have to put sim around this one. That would also work, because that's all that one does. Okay, so the difference is just that I don't have to type the silly sim. No, what is it? U, like this. There we go. Okay, that's all. Thank you.